Welcome back to Veterans Healthwatch. We're now going to be learning how robots can actually help veterans regain movement and other abilities after a stroke. Joining us now are Dr. George Wittenberg, Deputy Director of the Maryland Exercise and Robotics Center of Excellence, and Dr. Larry Forrester, Associate Professor in the Department of Physical Therapy and Rehabilitation Science and Director of the Human Motor Performance Lab at the Baltimore VA Medical Center. Doctors, thank you both for joining us today.
It's a pleasure.
Dr. Forrester, what exactly is a Human Motor Performance Lab?
Well, our lab is a facility that was provided to us by the VA R&D service several years ago to allow us to measure and quantify human movements. Because in our work in rehabilitation, we're interested in movement function. So if someone comes in who's had a stroke or some other injury, we can actually, for example, take three-dimensional films of their walking and discern what areas are a problem. And then if they go through a rehabilitation treatment of some type, say treadmill training, we can refilm them and see which areas may have been improved or affected by that sort of intervention. And along with that, of course, we have several other measures that allow us to measure muscle activity, forces generated, how strong they are, those kinds of things. And recently we've added the ability to study brain activity, which is something maybe we'll touch on a little bit later.
Well, Dr. Forrester, what types of issues do you look at specifically in people who've suffered a disability after having a stroke?
Right. Well, most of our work in recent years has focused on stroke. So many individuals after a stroke will experience a weakness on one side of their body, and this can affect their ability to use their arm and their hand to reach and grasp, and certainly in many people it affects their ability to walk in any sort of economic way. They often have a severe limp, and this limp poses problems that can lead to falls and certainly slower walking and less function in their daily activities. So as we come up with interventions like treadmill training or resistive strength training, we'd like to know how we can improve this walking ability. But the kinds of problems they have through the weaknesses, for example, if you'll forgive me, but they might have what's called foot drop. So the weakness down through the ankle doesn't allow them to position the foot to safely plant their foot and continue walking. Recently, to try and address that particular problem, we've collaborated with MIT up in Massachusetts to use a robotic device called the ankle bot, because we believe that by training with this device that perhaps we can enhance that part of the whole walking system to move them farther along than we have been able to do so far. And I would add that our gait rehabilitation studies have been very successful, but we're still pushing on for even greater success.
Well, to expand on that, Dr. Forrester, what has your research shown so far?
Right. Well, particularly with the robotics, we've been very intrigued. We have a setup where individuals sit in a barber's chair and they wear the robot, which hooks onto their lower leg, and essentially they play video games with their ankle. Mm-hmm. And we can construct these games to be easy or hard, and we try to make them incrementally more challenging as the individual is more and more able to use their ankle. Of course, in the end, and what one of our recent studies showed is that by doing this type of what we call visuomotor training, it's kind of jargon, but they're looking at a TV screen and moving their foot, it actually conveys to slightly better walking. So as preliminary work, it's encouraging, and we're continuing to pursue that. We've added, in the last year, with another VA investigator, the idea of adding a brain cap or EEG. And so we want to understand how the brain patterns that as a person uses this device may change as they become more efficient and effective. And again, this is a window on what we call motor learning, which is probably a very important process in rehabilitation.
This is really intriguing research. Thank you.
Well, Dr. Wittenberg, Dr. Forrester mentioned some of the lower extremity robotics, and what about some of the other robotic studies you have going on?
Right, so the work that I'm involved in is all focused on the arm, and so on restoring ability to move the arm, to grasp, and to do important functions with the hands during the day. And in stroke, this is very commonly affected. So we've actually completed some studies recently, including a VA cooperative studies program trial, which involved 4 VAs, of which ours was one. And this took people who had had a stroke more than 6 months ago and had rather severe problems in using their arm. People for whom it really wasn't thought that there was a therapy that could actually help them move better. And what we found is that with 12 weeks of intensive therapy with a robot, but also with other types of devices that allowed them to really practice movements, they got better. There were significant improvements in ability to move the arm and significant improvement in quality of life. Those results were published in the New England Journal of Medicine last year, and I think should really give a lot of hope to people with severe deficits after stroke. Another interesting side of that is that we tested the brain changes that occur with that sort of improvement, and found actually a more effective connection between the part of the brain that controls movements most directly with the muscles of the arm, and secondly, changes in the connections between different brain areas. So we actually are changing brains with this kind of functional improvement.
Are the robots that you're using as part of your research commonly used in physical therapy settings?
Mm-hmm. They're not very commonly used, but there's been a technology explosion recently in which the robots that we used, which were designed by IMT but now produced by a commercial company, and other companies have actually received FDA approval for these devices. And they're actually more and more present in therapy establishments around the country. But the research work that needs to be done to show who benefits from them, how they can be most effectively used, is still very much remaining to be done.
Well, Dr. Wittenberg, could you tell us about some of the results you found from these research studies, and what direction are you taking in the future?
Right. So, as I mentioned, we've shown that people can improve with robotic therapy. They can. We've defined exactly what sort of robots work best and what combination, and so we're basically refining the type of therapy that people get. What we're doing now is actually working on 2 fronts. One is how can the movements that are restored by the robot be best integrated into daily life, and so we've taken sort of the best of the robots that we've used so far and the best of the methods, and actually combined that with what we call a transition to task practice, where people start using those movements not to just move the handle of a robot in a video game, but actually do practical things like turning a key in a lock or drinking a cup of coffee, for instance. And the people who are involved in that study are getting now more detailed examination of their brain changes, and even how the connection between the motor part of the brain and their hands changes with a single session of therapy. The second thing we're doing, which I think is equally exciting, is that we're investigating how stimulation of the brain with a technique called transcranial magnetic stimulation can actually work together with practice to increase the amount of change that occurs with practice. And so in doing that, we're actually combining an external stimulus with a magnet to the brain along with a person's own decision and ability to move. So those are 2 studies going on right now. One for the first one for people who are more severely affected, and the second one for people with more moderate disability, so we can understand how we can tune up their ability to move at that point.
Dr. Wittenberg, we're going to be going to a break very shortly, but can you give our viewing audience some information how they might find out more about your program or how they could participate in the program?
Right. So recruitment into our clinical trial can be done by calling the same recruitment number that was given before, and which you should see now. For a study involving the stimulation with practice, we have a research coordinator, Jamie Lush, who would be happy to take your information.
Dr. Forrester, Dr. Wittenberg, thank you so much for joining us today. I really think our viewing audience learned a lot about what you're doing in your exciting research program.
It's a pleasure.
We're going to go to a break right now, but when we return, Chris Buser, our remote reporter, will be at the home of one of our veterans to show us and tell us more about the VA's new caregiver support program. So stay tuned.